I'm Jan Boyer, the Executive Director for the Pennsylvania Concrete Masonry Association and the Mid-Atlantic Masonry Association. We are happy to be the pilot program for introduction of this. So you all are seeing this for the first time really in the country, this particular presentation. We are happy to have Morgan Weiss and Rob Grant from Integrus Architecture to make this presentation for us. They, along with some other folks at Integrus, are some of the key authors for the BIM for Masonry, modeling masonry buildings in Autodesk Revit, and are very experienced. So without any further ado, I'm going to pass it over to Morgan and Rob, and we thank you for attending. You will get your certificate of completion after this is over via email. We will get a notification from Integrus as to who is on the webinar. So we thank you again, and thank Morgan and Rob for their time and efforts, and it's over to you.
Thank you, Jan. Go ahead and go full screen. There you go. All right. One second. All right. So my name is Morgan Weiss. I'm a professional engineer. I graduated from Washington State University, and I've been out of school for just under 5 years, and I've been using Revit since the day that I started here at Integrus. And I've been doing most of my own drafting in Revit for about 4 years, and my main focus has been K-12 projects.
I am Rob Grant, the BIM manager here at Integrus. I am originally from Montreal, Canada. Have been living in the States now for 14 years or so. Spent 6 years in the Las Vegas market working in hospitality and gaming. I've now been in Washington for 7 or so. I am in charge of both our Spokane and our Seattle office.
A little bit about Integrus Architecture. We have 2 offices, one in Spokane, one in Seattle. Seattle's office is on the left and Spokane's is on the right. One of the cool things we love is both are in older historic buildings in their respective cities. Our focus is things that we have passion for. So our Seattle office focuses on K-12. Our Spokane office focuses on higher ed, and then we do all types of civic work, convention centers, U.S. embassies, judicial, and security upgrades. The firm went full plunge in 2006 with Revit. They started exclusively using Revit, and currently all consultants need to be at least partially in Revit, and we'll discuss on some of this later, but we're also implementing internal disciplines working within the same model. And doing this allows us to work more collaboratively together because we're right there all in the same model.
The fun part, the disclaimers. We will be providing these slides afterwards, so if you really feel the need to read the disclaimers, they will be available. Same thing with the fun high-action step of a copyright. And then our course description.
The presentation provides case studies of building information modeling and masonry projects using tools available from BIM-M and commercial software. It will also draw on concepts from the document BIM for Masonry, Modeling Buildings in Autodesk Revit, and we will discuss the importance of BIM when moving from design to construction.
Learning objectives. Learn about current industry tools for use in Revit and Masonry to further the building design and detailing. Learn modeling techniques for Masonry use in Revit to further your construction documents. The case studies will show how BIM has helped with coordination building systems such as structural, architectural, and mechanical, and then discuss at the end, if there are some questions, using the case studies, the appropriate amount of modeling for project delivery methods.
So our presentation today, we're going to cover information about BIM-M, why BIM is important, why Masonry needed BIM, and what tools are out there currently. We're going to look at 2 case studies further in depth, and we're going to abbreviate another one. They are Park Place Middle School, Whitworth Music Facility, and Tyee Middle School. And then we're going to talk about what we do, some of our tips and tricks. Obviously, everyone has their own, but this is just some of the stuff that we have done and have been doing as a firm. So a little bit about BIM-M. BIM-M is Building Information Modeling for Masonry, and it was an industry initiative to further masonry in BIM. Hopefully you've all heard about it. If not, we're going to get into it a little bit here. So why BIM? For designers, better collaboration. You see the conflict. For instance, here we have a joist conflicting with a beam inside of a wall. How did all of this come together? If a duct goes by, how do we also make sure a mechanical duct's out of the way? For the owner, there's fewer cost changes. You catch everything ahead of time, or as much as you can. That gets rid of your RFIs, lowers the amount of change orders you have, and hopefully requires fewer site visits to look at conflicts in the field. And for a contractor, you get more accurate quantity and scheduling, better bids, great in a hot design market or building market for an owner. You can get more competitive bids, better pricing. And this was all kind of the precursor to BIM-M. So BIM-M is an industry initiative to unify the masonry industry and all supporting industries through development and implementation of BIM for masonry software to facilitate smoother workflows and collaboration across all disciplines from owner, architect, engineer, manufacturer, mason, contractor, construction manager, and maintenance personnel. And why? And the reason is other industries have invested heavily in BIM. I know steel had their own projects, concrete has their own initiative. There's a lot of add-ins for wood, cold form, a lot of national groups. But masonry tended to be more localized in nature. Out here we have the Northwest Concrete Masonry Association. Obviously we have the PCMA. There are also some national groups, but as an industry, it is a lot more localized. And so the goal is to speed up and provide better tools for the industry. If you had opened up Revit 10 years ago out of the box, there was really nothing for masonry. You had tools for steel, you had tools for concrete, but masonry kind of just got looked over. And so the whole point of BIM was to provide resources and tools allowing designers to efficiently move from BIM if you're currently in a CAD format. And one of the things that they found was some designers were actually shying away from masonry just because it seemed like it was a cumbersome product to use in Revit. And that's what really kicked off the BIM-M initiative. And so the tools that they have so far created, we have the Masonry Unit Database, which is currently just got released. There was the BIM-M Users Guide, which has been out for about 3 years now. BIM-M has funded CTC Express Tools, which is an add-in for Revit that gives you a whole library of both 3D and 2D content that you can use. So if you're just starting to move to Revit and you need things for, you're getting off the ground, you don't have a lot of content pre-made in your library, you can use this to help start building that library for you. And there's also future tools. They're working on currently some more 3D stuff that will help you model bond beams more efficiently, vertical reinforcing more efficiently, help with the collaboration. So it's something that's put out there for you guys to use. Almost all of it's free. If you go to bimformasonry.org, you can see all this information that's been provided for you. And now we're going to get into some of our case studies. And so this is, personally, I always love this photo just because it shows going from SD to the final product. And it just does a great job. We start up in SketchUp in the top left, and then the final photo with the students in the right. And you can see kind of a construction model, the design model, the SD model, and some renderings, and kind of just how it all came together. So our first case study is Park Place Middle School. It was a brand new middle school and a seismic retrofit of the existing gymnasium. It was 120,000 square feet of new school and a 20,000 square foot renovation. It was done in 2.5 phases. All was done in Revit, including the phase sequencing. On the left side was the existing gym and the off gym addition, and then the right-hand side is the new portion. And here's a view from the other side. It was all load-bearing CMU with veneer and metal panel siding. Break springs were proposed. but load-bearing masonry offered a cost-effective solution that allowed us to get that final result we wanted without losing the square footing to box-around columns, or losing square footage, sorry, that, comes with break rooms, box-around columns, things of that nature. So for this project, Park Place was a coordination tool and a production tool. It was the first program I opened in the morning and the last program I closed. It was really my main tool for both the construction drawing set and even structural design. So coordination was huge. So for instance, here we have some mechanical ducts, and they're located on the right in red. And we were able to handle issues before they arose. So this took place about 2 weeks before we went out to bid, and we were doing a final sweep through of mechanical, and we noticed that one of the ducts slid to be cutting right through the end of a wall, right where we have really 3 beams really coming together and going to be bearing directly over this. Had we not caught this ahead of time, this would have been an RFI, a change order. We would have had to pay for extra duct work to route it around the edge of the wall. So we were able to final this ahead of time. The reason you're seeing this this coordination view is because we caught this right before bid, and so we didn't do a final model swap, but mechanical did shift their ductwork over about 5 feet, cleared the wall, and when I went out on site, no conflicts. If we go through that same section, you'll notice if you actually measure, we missed it by about an inch. But the biggest advantage is everyone was on the same page. We noted it, the GC saw it. They go through and they'll go through and model everything again for their BIM coordination, but it's way easier to catch your mistakes 1 year before it gets built. We avoided the RFI, like I said. It would have been about 20 feet of duct. They would have had to bring masonry back in. Just a lot of problems get solved. And the deliverable method helped on this one as well, because we did have a contractor on board. So not only did we have our own eyes on it, but we had a contractor's eyes on it too, looking for conflicts such as this. And again, here's another MEP bucket we needed. The left was our drawing, and the right was what was built in the field. As you can see on the drawing, I had assumed it was a square opening. On the right, it was 2 round. One of the things, you can't always guess 100% what the openings are going to be, but the whole point is you're letting people know. And that's one of the big advantages. We can go through, we can see where the ducts are going to approximately be. We can, if we need to, we can dimension place 4 feet away from the edge of a beam, things like that. And that's why we do also make the note, GC to verify the final size and location. It's just helping make everyone aware. If we don't put this on our drawings, a mason, when they're going through their coordination drawing, they're not going to see it either. One of the things is we don't model everything in Revit. You hear a lot of stuff about people trying to model everything, and it becomes really hard and cumbersome. Here we have a huge amount of reinforcing in this wall due to the opening and the fact it was also a shear wall. And so this would have been really hard to model. So we modeled what we needed to, but we picked up a lot of our own stuff with line work on the base, and then we bring in those other coordination models to make sure that everything will in fact fit. But here you can see our lentils, our vertical bars, everything. But if we go to that building section, we didn't model things with a purpose. So we modeled our lentils over openings that way. They can make sure everything coursed out architecturally. There were no issues with the openings. They weren't going to need to cut anything on site. In some projects, it wasn't this one. We have modeled certain things like this so a contractor can do a quantity takeoff. So that's really helpful depending on what your deliverable is going to be. And also, if you have conduits or things of that nature, you can look for conflicts, like at the head of a storefront, how is stuff coming together. So the other thing we looked at was enhancing our detailing. So on the left is a live model, no enhancements. If you were just to cut a section through Revit, obviously there's a few text notes, but You can see just the modeled wall, the modeled veneer, the model insulation, the model foundation. And then what we'll do is we'll then overlay it with detail components to give it that extra emphasis. So you can see we added detail components for the coursing and veneer. We added detail components for the CMU, for the foundation systems. That way our model is kept lighter, but everything that we need is modeled, and then we'll just enhance it to get that final look that we're desiring. And again, here's just another example of that. And within our office too, we'll get people that will use, I believe, like this one on the right, they'll use a live model and overlay it. And the biggest benefit there is as stuff changes, you'll see your detail component no longer aligns with your model items. So it makes it a lot easier to track changes that way as well. Did something slide you weren't expecting to slide? Because you have these 2D detail components overlaid with the 3D, it's really easy to see conflicts like that. Another example is detailing based on the model to help make it more accurate and make sure everything fits. So on the left was my 2D detail, and on the right was the live model cut. So I went in, and on that live model cut on the right, I went through and overlaid everything with line work and detail components, and I was able to make sure it could fit. So this is a drag strut connection, and as you can see in the model, that beam's 2 inches away from the end of that CMU wall. So I was able to make sure, place it 10 inches away so they could actually get the connection in there and make sure it would all fit. And here was the final product, how it turned out. The GC, when they built it, they had no problems getting it together. The masons knew exactly what needed to happen, where it needed to be. So by just using the model to enhance our detailing and help figure out problems like this in the construction field, there was no problems. And this was one where I was concerned that we might have had some conflicts. Another one is our detailing based on as-built. So that's another big benefit was we had our as-built for this project for that existing gym retrofit. And when we went through, we had realized that the existing building was off by 4 inches in the bottom 2 corners. One side was about 2 inches further north, and the other was about 2 inches further south than they were supposed to be. And what this allowed us to do was figure out, okay, how is this going to exactly come together? The original thought was we were just going to put the new wall tight to the existing wall, but we had this now skew we needed to worry about, so it allowed us to look, okay, how do we want to connect this? You know, do we need to look at anything else? How is the existing roof connecting to the new roof? What's the best way to handle something like this? And as you can see, this was a photo of the existing wall. There would have been no way to figure that out. And we went through a couple iterations, but we were able to work through it because we had that 3D. And we ended up discovering that we could just build the wall tight. We were able to make other adjustments, but we went through probably 2 to 3 different scenarios of how we were going to make this happen.
Our second case study project is the Whitworth Music Facility in North Spokane. This is a new music facility designed to help with the program in issues of outgrowing its existing space. We added a 22,000 square foot addition with a minor renovation to the existing structure. The front portion that is seemingly clad in a brick was the new addition, and then the existing is on the right-hand portion of your image. Integrus is the proud recipient of the 2017 Robert Fraser Excellence in Masonry Award for this building. We've also received a few recognitions from the AIA as well for this project. So in this project, there was a significant amount of load-bearing CMU and veneer. If you actually look in the lower left-hand corner, I'm going to be discussing this double cantilevered opening, just to give you an idea of reference of where we are on the project. Our biggest feature was, in fact, these double cantilevered lintels. The joists penetrated the lintels. Structural engineers had to detail everything to transfer all these forces. One of the biggest reasons Morgan was discussing a while ago that we don't model everything mainly rebar, is that you can see in this kind of an image how much congestion we would have. We are blessed in our market as of right now. We don't have to do all the modeling, but that time is coming. So being on board with how to get things done early is going to save us a whole lot of headaches later on when they do require us to model everything. As you can tell also, I've got highlighted on the right-hand side one of the openings. The ability to see everything in a 3D model is immeasurable for coordination. Again, this is another perfect example of how congested our rebar can get. The ability to use Revit is, as always, it's fundamental. We also use Navisworks for clash detection. However, the reality is we're getting so much out of our Revit environment because we're utilizing both structure and architectural teams together. In this portion, there is a 40-foot main lintel adjacent to a 10-foot corner lintel that connects to the other side that you kind of saw in the previous picture. This is also the same corner that I showed in 2 slides earlier, that corner condition of window glazing. Thankfully, on this side, we didn't have any penetration through while creating an easy coordination with our consultants. Our modeling, our hyper-modeling, while maintaining low data for things like the rebar, allowed us to preemptively coordinate everything, and we completely eliminated RFIs on anything related to the masonry and our double cantilevered lintels. Here's a simple view of the 2 different double cantilevers. The smaller, shorter one on the right is the one that I was actually highlighting a while ago. The larger one on the left is the 40-foot opening that you saw in the previous slide showing all that rebar. And then there's this final image of the finished product. Admittedly, this image, in my opinion, doesn't do justice to the project. The client has been so content with the result and the cost savings due to the lack of RFIs and the clarity and coordination that we had, that they actually immediately turned around and hired us for 2 more projects. And they put a special emphasis on more CMU and masonry to be used on those projects for the sake of continuity across the campus. We've also received incredible praise from the students. One of them is a piano player. You can see that this front corner room right here is actually the piano practice facility. They praise the fact that they've got this just open view to the whole campus. So going back and discussing more of what Morgan was saying, where we use a live model with a certain amount of information overlaid with detailed elements. On the left-hand side is the structural view that is actually modeled. You can see that we keep things fairly limited in terms of graphical representation. On the right-hand side is actually the same condition that we detail to a higher level for our construction documents. So here's 2 examples of our built condition. The door support that you're seeing on the right-hand side is actually the condition that was shown in the previous slide. This is, it's instrumental in allowing us to make sure that we've got the right brick coursing for our veneer. And then on the left-hand side, that I'm going to continue discussing here in a few more slides, shows some of the congestion of steel that we have going on our projects. To slightly beat a little bit of a dead horse here, here's another slide showing the difference between the live section. Now, admittedly, this live section doesn't go deep enough to show, but we have modeled the rest of the beams. However, on the right-hand side, what you're seeing is the 2D detailed element of everything for the construction documents. And here they are overlapped. So really, we're getting everything accurately drawn for them. We're getting everything taken off properly. And that's all the information we have. So not everything needs to be modeled up front, but sooner or later it's going to show up. It's going to be clear as can be. Returning to existing or real construction pictures on the field, Here's the steel. Clearly, it's a congested condition. The steel that is shown is everything that would have been modeled. We're basically modeling everything except for rebar, as we've said a while ago. Our general contractor has noted also that we are apparently not afraid to use a whole lot of steel to make sure that this masonry supports itself. The end result in this condition is a very nice floating looking section of masonry. The walkway looks like it has just this nice thin wafer hanging over it. We have stood on site and just watched people walk in, and they walk in with this look towards the sky like something's about to fall on them, yet it's just beautifully coordinated.
So now we're going to talk about Tyee Middle School, which is in Bellevue, and we're going to just talk a couple highlighted elements of some of the BIM use when we were working with masonry on this project. So one of the first things is coordination. So our consultant in this one was using 2D AutoCAD. This project took place right after the firm became a full user of Revit. Our consultants weren't required to be full users of Revit at that point. And as you can see, here was our elevation on the left. And you can see there's no penetrations there. I specifically highlighted one location, but there was nothing shown on this wall except for the door openings. If you look at that photo on the right, the built condition, you can see there are a lot more penetrations than thought. There were 2 duct penetrations, a bunch of piping and electrical penetrations, and none of this was accounted for ahead of time. The reason is when you're working on those 2D, a lot of the time it was simple lines. The coordination was hard to overlay. And here, even though we were in Revit, because our consultant wasn't, we weren't able to catch these ahead of time. So it became an RFI, go through that whole process, having to do field fixes. The project slows up a little bit. So it really shows how you can catch stuff ahead of time. It really helps you with your whole team being in Revit. And here's another example. This one was with electrical. So this is our shear wall, and they wanted to place the light switch and some overhead signage right in our boundary element and our lintel. And so the consultant, again, was only using 2D AutoCAD because it was just becoming that industry standard. We were adopters, but not everyone was. And nowadays, because all of our consultants are also in Revit, we can coordinate all this better. We know to make sure we have extra space for the light switches right at the ends of our walls. Do we have, like going back to that choice example, if we have a large item mounted above a door, do we need extra room and extra rebar to accommodate that recess right in the middle of our lintel? And general contractors, too, are getting on board with BIM and Revit. All of them, I think on all the projects I've been on now, they're on doing Navisworks collaboration, Navisworks coordination. Some of them are even starting to give us submittals that they did in Revit for their self-perform packages. And the last one from Tyee was a high window. So the window basically went to the underside of the beam, and because of the construction, they needed a solid surface to mount to. And if we had our standard beam pocket at some of these windows, it wouldn't have been constructible because they would have went to place the glazing, but the glazing install would have happened before they were able to do the grout backs at the beam pockets. So instead, we were able to coordinate it, notice the issue with these beam pockets and how the storefront was going to be installed, and we were able to go through and switch to these embed plates. We went through the entire project and swept for all these conditions. And it was, again, someone in BIM noticed it and said, oh, we might have this potential problem. And they went through and talked to a GC and said, yeah, you're going to have a constructability issue. So again, solving problems before they happen.
So our design and documentation process includes a myriad of software solutions. Revit is obviously the biggest one. There's other solutions. There's ArchiCAD. There's SolidWorks. There are other solutions. We also leverage Navisworks in-house. We also have other software such as Enscape for our presentations. We've been dabbling with Google Cardboard for walkthroughs at different stages of construction. Navisworks allows us to do some quantity takeoff as well as the clash detection. And then there's other new ones to the market, such as the CTC tools, the Express tools. that Morgan was mentioning earlier. CTC Express Tools is actually supported by the BIM for Masonry organization. It has a myriad of stuff in there. It's updated frequently, so that's definitely something to look into. When we discussed this for this image earlier, it's just a great representation of how everything comes together in a way that is accurate based on what our design intent was and everything we did for coordination. So you've heard us discuss a little bit the idea of a one model. We are admittedly blessed. We have structural and architectural and interior design all in-house. It allows us to reduce the duplication of information. The majority of firms in the industry, what is happening is that the architect is drawing something to show his intent. The structural engineer is using, within Revit, for example, they're using the copy monitor tool for load-bearing walls. The architect is having to coordinate with that. It creates a duplication of effort, which duplication of effort is duplicated man hours and therefore a loss of profit for everybody. The other beauty of a one model environment is that it forces more collaboration. That collaboration inherently becomes more cohesive team members, and a more cohesive team is just better for everybody. There's obviously, as we've discussed several times, the near instant clash detection, and then there's the non-specific changes, the increase in communication like we were saying, and then lastly is the rise in profit. We, for many years, actually, when we first integrated Revit, we were using the traditional path where the structural team had its own model and the architectural team had a model as well. Our coordination was definitively better than most environments where you're in two separate buildings. However, we realized that being in a one model environment was a fundamental thing that we had to invest in.
And real quick to add to Rob, because I've had some really good luck with this. One of the things, too, is he said it's that near instant clash detection. So the nice thing is because we're in the same office, you're not swapping models every other week. We're right there. So I'm working on a project right now, and the architect turns around and says, hey, can we move this brace frame column? Can we, this column by our stairwell, can we shift it 10 inches? And I can go look at it, analyze it real quickly. Is this a feasible move or not? And then I can tell them yes or no, and then I can move it, and then when I save, they'll reload, and within, 2 minutes, they're working on the most up-to-date model. There's no trying to track changes as you swap models back and forth every couple weeks.
So there's also solutions from Autodesk right now. There is A360, or what they're calling BIM 360. They've dabbled with a few different names. It's not to sell their product. However, that is pretty much as close as it gets to a one model environment while being in separate buildings. The beauty of that one is you're able to see the changes reflected immediately. You're not having to coordinate multiple models between multiple firms. However, there has been some hiccups. You are susceptible to the cloud. You are susceptible to internet outages. You are susceptible also to distance between said buildings. So there are other alternatives to the one model without being all under one roof. So we're going to discuss a few things that we do for our modeling. One of the things we do, I didn't put it on the insert here, however, we also often have separate walls for our structural and our architectural teams. So we break down the walls to a structural level that allows the structural team to manipulate their walls, and then we skin it with a finished architectural wall in front of that. It sounds a little bit more tedious. However, it actually lowers the number of wall types you have. The number one problem I see is teams will try to make a wall type that goes from the interior face all the way to the exterior face, where it includes everything from the CMU to the studs to the drywall to the brick veneer on the outside. And the problem is literally you will turn the corner around the building and you'll wind up with a different condition. So they have to make a whole new wall type to answer to that one specific condition. If you break it down so that your interior, say your interior furring and drywall finish is one wall type. Chances are you're using that elsewhere. And then the middle core of CMU is a second wall type. Chances are you're using that somewhere else. And your exterior finish literally handles just the airspace and the brick veneer. Yes, it makes it a little bit more confusing because you've got three wall types, but the reality is it's so much easier for the users to manipulate and change things. So next up, we also model all of our, we use wall sweeps for our sills. It helps with the coordination and detailing. It's also much more realistic for our presentations. We're going to decline for a minute. We'll come back, Edward, I see your request. We're going to decline it for a minute. We'll come back to it during the Q&A. I've marked that it's page 47. So we've got, as I was saying, so we're using wall sweeps for our sills and our conditions. We also use our wall reveals, and you're going to kind of see that in the second line here and the third one here, to do our control joints. A lot of companies like to use either a monoline or just a detail line in elevation. We prefer to actually have a reveal. That allows us to see it in elevation. It allows us to see it in plan and sometimes in sections, depending on which way the reveal is going. The beauty of using an actual sweep where it's cutting the face for you is you don't accidentally have multiple people modeling the same thing in different methods. It works again, just like the sweeps, the reveals work best for the presentational purposes, and it really allows you to line up nicely for your brick coursing. Apologies here, nope. So the wall sweeps, like I was saying, you get to see it in your 3D, you'll obviously get to see it also in your plan, or your section in this condition. What we're not seeing, because it was actually fixed before we were able to take a picture, on this right-hand side, the reality of what was originally happening was that stone cap was floating a little bit too far. It allowed us to catch that. We were able to add some support behind that using steel. Modeling basics. Keep it simple, stupid. I'm not calling people stupid. I just like to say keep it simple, stupid. The biggest reason why I like to keep it simple, stupid. What happens if somebody leaves that team, they decide they want to live back close to mom and dad, they moved across the country, they got hit by a bus on the way into work tomorrow morning. What happens if somebody is modeling something in an overly complex manner? The keep it simple, stupid method is in my opinion, a foolproof way of doing it. It also helps keep it lean. And then next up is don't be afraid to explore. So users will ask me on a regular basis, hey Rob, how can I do such and such? I will tell them, trial and error. Take the section that you're looking at modifying, copy it, paste it into a new project, just start up what I like to call mock projects. Just dump it in there, test your idea, see if it works, see if it doesn't work. That way you're not doing it in the actual model. And then last but not least, Dr. G, good old Google, it doesn't hurt to dig in to try and find new ways of doing things.
So for reinforcing, we still use 2D reinforcing for a lot of our purposes. As you saw in some of the case studies earlier, it's a lot of line work. It requires a little extra coordination, but there is this faster to draw. It is really easy to do line work versus modeling rebar, especially in masonry, making sure you're on course, right elevation, right offsets from the wall face. The main reason we don't utilize 3D reinforcing is changes time and model size. For instance, in Park Place, there was that one wall that had a lot of openings in it, that had a lot of, it would have a lot of hairpin ties. Modeling something like that would, if anything changed on that wall, it would be very time consuming to go back and remodel all that. If the windows shifted, 2 of them shifted 8 inches and 1 grew by 4, that would take a really long time to go through and update all that rebar. And that goes along with the time. As everyone knows, it seems like our projects, we keep getting tighter and tighter time schedules. So trying to overcome something like all that time we spent remodeling is just not worth it. And the last is model size. 2D line work, it's a dumb item. It doesn't hold any information. However, it's really quick and easy to change versus with that 3D reinforcing. It holds material properties, the weight of the rebar, the diameter, all of that information, and that takes up more memory. So if you were to go through and model all that, you could really start to bog down your model. Using the 2D reinforcing, it still provides benefits. As you can see here, we have our beams, and this is my favorite photo for showing this. We have all 4 beams aligned with all 4 jam steels. So we can catch this ahead of time on elevations and shift the beams. That way, in the field, we don't get that RFI saying we have steel conflicting in every single jam. And lastly, we're not a contractor. We're not doing quantity takeoffs in our office. It's not part of what we do. So that's really where something like modeling all the reinforcing would be beneficial. Is if you're a contractor, I want to get that perfectly accurate quantity takeoff. So we do use 2 live sections to create these details. So again, as we had mentioned previously, we took the section cut, see how everything fits together, and then we overlay them with 2D components. That way it's nice and light, but we know everything fits. And when you're working with the plan and detailed views, you can align stuff. I'll talk about it in a second, but that's one of the ways I work is I'll align and I'll copy them back and forth and make sure the 2 details actually align. So if I'm showing my bars on the inside face in one detail, I make sure they're on the inside face on my other detail as well. And so this is that process I was talking about. So I cut one section in elevation, and I'll cut another one in plan. And typically, I'll go ahead and lay out my detail in the elevation, and I'll move to that plan detail, and I'll just copy all the 2D line work above. And then I'll use reference lines, and I can make sure everything aligns. Because one of the problems if you're not doing this, it's really easy to think, oh, I have my ties here, but you might swap something, and then you get in the field, and they can't make sure anything fits. So this is one of those ones, and there have been some times if it's been really congested, I have used some 3D reinforcing to make sure it fits. I'll work between sections, but then I'll come back, and I'll just overlay that with the 2D. That way I have a nice light model. So you can use that 3D to kind of just help make sure everything's going to fit. So our current deliverables, we mainly perform design, bid, build projects and design build. And most of our projects, we go typically to an LOD of 300 or 350. The reason for that is, like I said, we're not a contractor. A lot of our projects don't have them on board. The ones where we do have them on board in design build, those are the ones we'll go a little bit further because the contractor has that additional benefit. But for us, there's little benefit and stuff changes post-bid as well. That higher level of development, you have more fees, so you have to go a little bit further. You have to make it worth it for the owner. In the private sector, obviously going to a higher level of development would make a lot more sense. You're going to have the owner and the contractor on board. Sometimes I've heard case studies on projects where they've been able to skip the shop drawing phase or greatly reduce it because you actually have the shop drawing guys doing that portion of modeling for you. So as an engineer, you would send your rebar markups to them, and then they would detail it for you. And the hardest issue of all is getting building officials on board. Right now, they don't have a lot of Revit experience. How do you document something in a model for a building official? How do you go through the permitting process and have them buy off on something like that?
So to come back to the discussion of some current industry tools, obviously, as I was mentioning, we've got Revit, ArchiCAD, and Vectorworks for your base drafting and modeling software. The BIM-M Revit User's Guide, we've been contracted ourselves to do some videos. They have been released on the BIM-M website, so that is a resource that's available for people for learning. There are plugins. Dynamo is probably one that you may have heard of in the last, I'm going to say, few years. It is not the easiest thing to learn. This is one of those things. I love Dynamo. However, I have my reservations against it because of the good old keep it simple rule. A Dynamo user today may not be here tomorrow, and I might be limited by what I'm able to manipulate in the model. There is also the CTC Express tools that, again, BIM-M Group has been backing. There are other tools like Hatch 22. It's a tool that helps you make some hatch patterns. Admittedly, there's already a significant amount of hatch patterns already created and available if you just take good old Google. But admittedly, on almost a weekly basis, I will have somebody come up to me and say, hey, Rob, I need yet another hatch pattern. We're using a specialty veneer. We're using a specialty size, you name it, specialty brick, and so on. So I'm constantly making new hatch patterns for my users. Industry tools, BIM managers. Admittedly, not all firms are large enough to justify the financial cost of a BIM manager. There are some consulting, if you are in a situation where you're a firm looking to kind of have consulting from a BIM manager but not have somebody on your full-time payroll, there are some BIM manager consultant firms out there. There are some great little ones. There are some great large ones. So if you're curious about that, I know of a few as well. Other industry tool that we discussed is the A360, the one model approach. It's you'll sometimes see it named BIM 360 or B360. So the one model approach, that's a tool that's available. It does come with a subscription fee through Autodesk. Of course, that's what they love to do to everybody. And then there's a plethora of structural software. Of course, now I'm blanking on the names of them. TEDS is one of them.
Yeah, and with it too, there's a lot of them. They're starting to integrate with Revit, and that's what they're really working on. Is I think it's Tekla has one, I believe. There's a lot of them out there that are all trying to find ways to integrate with Revit, and it seems like every year they're getting better at doing it.
Continuing on the more tools and continuing educations, the conferences are invaluable. I show a slide for Built by RTC. There's also Autodesk University, which is a huge one. The beauty of some of these conferences, while they do come with a steep cost at times, the builds by RTC, the beauty of that one is the vast majority of the presenters will give away their content. They'll give away the slides, they'll give away the families that they're demonstrating, and a whole slew of content. And the learning material is always available by slideshows. Autodesk University actually video records their presentations, so if you're in one class but there was another class that was interesting, it's still available after the fact. Another tool is listening to webinars. On that, we thank you for joining us on our webinars. There is also good old YouTube. And then if you become a little bit of an expert, teaching others is an invaluable thing because teaching leads to learning. I so often find out new things or remember things that I hadn't done in a long time because somebody has come up to me and said, hey, can you teach me about name the tool, and I wind up in a rabbit hole of new features or old features that I just completely forgot about. And then the last one, like I said, trial and error, mock projects. You cannot go wrong, in my opinion, with firing something up, copying from one project and dumping it into the next.
So where do we go in the future? Eventually, we are, currently we're keeping it light. That's how we're effective. But everyone sees it coming. There will be a day, eventually, we're going to model everything down to the last fastener. Until we get there, you'll see programs and their capabilities continue to grow. BIM-M, like I said, they're there trying to develop tools to make your modeling life easier. And eventually, the whole model will be a drawing set. And it's actually one of my favorite things when I went to one of those conferences a couple of years ago. They talked about there was a project in Australia, and the final thing they turned into this city for permit was a spec book and a model, and that was it. There were no drawing sets on that project. The GC had 2 iPads, one for his morning and one for his afternoon, and as he walked around, he just used the iPad to look at the model the entire time. So, obviously they were pushing the envelope quite a bit. They had to get their building official on board, but they were able to cut a lot of time out of their schedule by not having any 2D drawings as part of their deliverables. Shop drawings were 3D. The whole thing was a 3-dimensional model. So it is something that's coming. Some people are starting to do it, and we'll just see where it goes from there.
So again, thank you for joining us for our webinar. We are pleased to say this concludes the webinar. I'm going to minimize my screen here. And I believe that there was already a triggered up question here, so let me try to dig this out. Where is, oh, that's not on. I'm not seeing chat. apologize, we didn't realize that there is an echo. And then lastly, monopoly for Autodesk, Kevin, Ryan, yes, you are right. There is a little bit of the ongoing monopoly from Autodesk, especially when it comes to the BIM 360, the A360 environment. I have seen some companies looking at alternative solutions for a 360 environment. The biggest problem with the 360 environment that tends to be built in when you're trying to move away from the monopoly from Autodesk is latency because of different locations. We would specifically probably encounter that because some of our projects are fairly well sized, especially some of our judicial work. We have consultants pretty much around the country, so we're starting to lean into the A360. The other problem to kill Autodesk from their monopoly is the reality is we also have a certain segment of our portfolio that I absolutely refuse to put on the cloud because they're U.S. embassies. I'll let you play the political math on that one, but there's just no way I'm going to put some of that on the cloud. So I hope that answers the question of the monopoly for Autodesk. Evidently, the continuing rising prices is a shareholder discussion to be had at a larger venue.
We'll wait a second to see if there are any other questions. And then if not, we'll...
Lastly, I believe, Jan, we are able to track everybody that has joined the webinar. So your certificate will be sent to you. I know that Jan will be taking care of that. So don't fret on that. And then I'm going to unmute Jan here in case she has something to say.
Yeah, we just appreciate this information very much. It's kind of a bit cutting edge on this side, but we're looking forward to seeing where this goes in the future. And we really appreciate your sharing some of the nuances and some of the tricks that you guys use currently to be able to design with masonry. That's the issue. And this BIM for masonry and the information that's on the BIM for masonry website is invaluable as well. So we thank you so much for providing this information, and I thank the attendees for participating.
Okay, thank you, Jan, for this. It's always great to be able to share our knowledge. Admittedly, I love teaching people what I know. So.
Well, thank you all, and have a great afternoon.
Likewise.
Okay, bye-bye.